Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamu alaikum little kids. This is Shehroz Abdullah, and now today we are going to discuss friction, types of friction, static friction, kinetic friction, their coefficients of friction, their graphical interpretation, methods of reducing friction, advantages of friction, disadvantages of friction. This is class 9 chapter number 3, dynamics, lecture number 4. We are going to discuss. Let me recall previous work, what we have done in the previous lecture. In the previous lecture, we have discussed momentum, we have discussed change in momentum and Newton's second law, we have discussed rocket and jet propulsion, and all the things we have discussed in the previous lecture, right? And now today we are going to discuss all the details about friction. First of all, we need to understand what is friction. You know, friction is a kind of opposing force when one body is moved or rubbed in another body. So the kind of opposing force or resistive force produced over there, that is known as friction. Okay, so we define it like this: the resistive force which opposes the motion of object while it is in contact with the surrounding is known as friction. Okay, it is represented by small f. It's a vector quantity, and the SI unit of it is Newton, right? Okay, the example of frictions are rubbing of hands, ball coming to rest. Like if a ball is moving on the ground, right, it comes to rest. Why? Because of friction. It's actually continuously coming in contact with the ground, so due to friction it comes to rest. Okay, let's discuss microscopic basis of friction. You know, the bodies are looking actually smooth, but when their bodies are actually rough. Okay, when we see through microscope, still the bodies looks rough. Okay, even smooth bodies, when we see through microscope, it looks rough. Okay, you know, there are some irregularities on the surface of the body, so these irregularities bumps into one another, which give rise to frictional force. Okay, secondly, at this point the molecules of different bodies are close enough so that they exert strong attractive force on each other, thus opposing motion and results in friction, right? Okay, then we have normal force. What is normal force? You know, a contact force perpendicular to the contact force perpendicular to the contact surface that prevents two objects from passing through one another, known as what? Normal friction. It is represented by capital F to the base N. For example, okay, we are having a book laying on the table. So what happens over there? The book has some weight which is vertically downward, while the opposite force or reactional force is upward, right? That is perpendicular force, which we call a normal force. Okay, then we discuss what is static friction. You know, static friction, the frictional force that tends to prevent the body from starting motion, or in other words we can say the frictional force that tends to prevent a stationary object from starting to move is known as static friction. We can define it another way. Look, the force of friction acting on a body when it is at rest, known as static friction. Okay, for example, pushing of heavy crate. You know, when we push a heavy crate, we apply external force. Okay, the crate does not move. Why? Because static friction is very greater in that case. Okay, we further apply some more force on it, still the crate is not moving, still the static friction is opposing the body to stop it from the moving, like it doesn't allow the body to move. Okay, again we apply very greater force on the body, so the body starts moving. So what we have done, the magnitude of static friction is in this case was less compared to the applied force. Like applied force was very greater, that's why the body started moving. Okay, we have overcome the static friction so that the body is taken start. Okay, now static friction is represented by F, small f to the base N to the base S. Expression for coefficient of static friction. Okay, coefficient of static friction Fs maximum directly proportional to Fn. Fs maximum, we write a constant over here, and the constant over here is mu s. coefficient of static friction, what we call, coefficient of static friction depend upon the nature of the surface, like on which surface it is moving. Okay, then we come towards kinetic friction. Kinetic friction means the frictional force that acts against during motion of an object in a direction opposite to the direction of motion is known as kinetic friction. Okay, then we can define it by another way. How? Look, the force of friction acting on a body when it is in motion is known as kinetic friction. Kinetic friction is basically represented by Fk. Okay, when the carrot was like we were having a carrot, we have applied the very greater force on the carrot. The carrot started moving. Means kinetic friction is less than static friction over here. In order to drag the heavy carrot with constant velocity, we have to reduce the force to make it equal to kinetic friction. Okay, so this was all about kinetic friction. Let's discuss the expression for kinetic friction. Expression for kinetic friction will be Fk directly proportional to Fn. We introduce a kind of a constant over here, and that constant is mu k. Mu k is coefficient of kinetic friction, and that depends upon nature of the surface over here. Okay, then we discuss graphical interpretation. Look, on the horizontal axis we have taken force, on the vertical axis we have taken friction. Okay, static friction. Okay, what happens over here? We are applying force on the carrot. Okay, like we are applying force on the carrot is not moving. So again we are applying the force on the carrot is not moving, because applying force, because static friction is not allowing the body to move. Still again we apply the force on the body, the carrot is not moving. Again we apply the force on the body, the carrot is not moving, and a position and a state reaches where the static friction magnitude becomes maximum. If we apply more force at that point, then the body will start moving. Then the body will start moving over here, and the body will have some kinetic friction value that will be Fk. Okay, this region was static region, this region was kinetic region. Okay, now let me discuss what is rolling friction. The friction produced by rolling the surface of one object on another object known as rolling friction. Okay, the force which opposes the rolling of a body on another body is known as what? Rolling friction. Okay, for example, a cyclist applies brake to stop the cycle. What happens over there? The wheel stops rolling and begins to slide over the road. Since sliding friction is much greater than the rolling friction, therefore the cycle stops very quickly. Okay, now we are going to discuss what is advantages of friction, what is disadvantages, and methods of reducing friction. Advantages of friction, it enables us to walk on the earth, right? It holds the screw and nails, right? It lightens the match. Okay, what is the disadvantages of friction? Disadvantages of friction are it slows down the moving object. Okay, it produces heat. Energy is wasted to overcome friction. Produces wear and tears. Okay, then methods of reducing friction: we can reduce the friction by polishing the surface, by applying some lubricants on it, by using ball bearings. So this was all about today's lecture, right? Let me summarize today's work. What we have discussed today: we have discussed friction, we have discussed microscopic basis of friction, we discussed normal force, we have discussed how normal force affects friction, we have discussed static friction, we have discussed expression for coefficient of static friction as well as kinetic friction, as well as coefficient for kinetic friction, graphical interpretation, rolling friction, advantages, disadvantages, and methods of reducing the friction, right? So this was all about today's lecture. Hope you have enjoyed the lecture. Thanks for watching. Allah Hafiz. Fi Aman Allah.